Welcome to Chapter 5, where we're going to be learning about the term structure of interest rates, well, bond pricing, bonds, and the term structure of interest rates. And we'll be doing it all on NyQuil. So before we really get too far into this stuff, I do kind of want to talk about this a little bit. I am by no means an expert in any of this stuff. In fact, I am so not an expert at this that I actually kind of borrowed some of these notes from a different professor, Eric Sims at the University of Notre Dame. So thanks, Professor Sims. These notes are awesome. Um, and yes, I kind of took that and sort of, I made it my own. I didn't just, steal his notes and just start passing them off as my own. I made a little bit of the stuff my own, but let's say influenced very heavily by that. Because again, I'm not really an expert when it comes to bond pricing and when it comes to the term structure of interest rates. I really understand like the yield curve. I can explain that to you guys very well. But getting into like the nitty gritty of it all, it wasn't really my thing. I never really studied it in graduate school. I studied other stuff instead. But this is kind of important for you guys to know. So I did just want you to be aware that this is not my area of expertise. So what is a bond? Well, a bond it's like an IOU, right? It's a financial security that entitles the holder to these periodic cash flows from whoever sold the bond. Um, the borrower sells the bond to somebody else, right? So you write up this bond. It's really just a super expensive piece of paper, and you sell it to somebody with a promise to pay him back plus a little bit of interest. And that interest is the incentive for them to want to buy the bond from you in the first place. Now, these bonds will pay back fixed and known payments according to whatever this pre-specified schedule is. Generally monthly payments, but it could be quarterly, semi-annually, annually, whatever. And these bonds are basically fixed income securities. Whereas, like, say, equity would offer unknown payout streams. And there's different types of bonds, and they differ by details on like how the bond is paid off, the time to maturity, and the default risk. The yield to maturity is the interest rate on the bond, but the interest rate's not always explicitly laid out. Now, interest rates and yields are the same thing. And we're going to learn how interest rates get determined and how and why they vary across different kinds of bonds. Now, I typically use this capital R as the nominal interest rate. Here I'm going to be using a lowercase I, and the R is going to be the return on the bond. This is a deviation I really only use in this chapter because interest rates and returns are not always the same thing. In all other chapters, this capital R will be the nominal interest rate. So this is, like I said, the only deviation. On exams, you'll know which one's which. So I hope this kind of clears up some confusion. Anyways, getting started. What is the discounted present value? Well, the discounted present value of something is today's value of what you would be getting in the future. So, like if you win the lottery and they tell you can either get the stream of payments or you can take this huge lump sum, that lump sum is the discounted present value of the stream of those payments that you'd be taking otherwise. The discount rate is the rate at which you discount the future cash flows from a security. And for a cash flow, it's how many dollars would be equivalent to you today. So it's like the question would be if you can get $1,000 next year or you can take something today, what is $1,000 a year from now worth to you in hand right now? That's the discounted present value. And what it would do is it would take the cash flow over n periods or n periods from now divided by 1 plus the interest rate to the number of periods that we're moving forward in the future. So let's say you can get $10 in one period, or you can get the present value of it today. What's the present value? Well, you could put $1 in the bank today and earn, say, 5% in interest. Okay, so that means the interest rate would be 5%. So you'd have 1 plus that nominal interest rate times the present value being equal to the cash flow at t plus 1. Or the present value is equal to the cash flow divided by 1 plus that interest rate. Okay, what's 1 plus the interest rate? 1.05. So it's 10 divided by 1.05 equals 9.52. Now let's say you're promised $10 in period t plus 3. Well, again, you could earn 5% for every dollar you put in the bank each period for 3 periods. So that would be like the present value of present value times 1 plus the interest rate times 1 plus the interest rate times 1 plus the interest rate, because we got 3 periods that this compounds, right? That's 1 plus I to the power of 3. So it's CF t plus 3, cash flow, 3 periods from now, divided by 1 plus the interest rate to the third power. It's 10 over 1.05 to the third power equals 8.64. Now, a financial asset is something that entitles the holder to these periodic payments or cash flows. The classical theory of asset prices is that the price of an asset is equal to the present discounted value of all future cash flows. And the price of a bond, or really any asset, is the present discounted value of cash flows. The yield is the discount rate that you use to discount those future cash flows. So it's also equal to the expected or the required return, not necessarily equal to the realized return if the security is sold prior to maturity. And the key issue here in asset pricing is how do you determine which yield to use to discount cash flows and hence price an asset accordingly? Because the riskier an asset you have, the higher the required return will be that you're going to demand in order to hold this thing, right? If it's super risky, it's a high chance of default. You're going to be like, yo, I want higher returns here, because you want to be able to recoup as much as you possibly can before this damn thing defaults. Therefore, the more you're going to be discounting future cash flows. So there's different types of bonds. One, there's a simple loan, like you borrow a certain number of dollars and you promise to pay 1 plus R times that number of dollars back at some specified date. So, you borrow $100, you got to pay it back next period, 5% interest, you pay back $105. That's a simple loan. There's a fixed payment loan where you borrow, say, $100 and pay back that same amount each period for a specified period of time. That would be something like a car payment, right? You buy a $20,000 car, you got to pay, $400 a month over however many months, something like that. There's a coupon bond. Well, again, you borrow X number of dollars and you agree to pay back fixed coupon payments, C, of each period for a specified period of time, at which time you pay off the face value of the bond. And there's a discount bond. You borrow X dollars and agree to pay back Y dollars after a specified period of time with no payments in the intervening periods. So that's like there's no regular payments. It's just you borrow $100 and you agree to pay back, say you pay $150, and there's no payments between now and, say, a year from now, and you got to pay it back. So typically that Y is larger than X, thus the bond sells at a discount, hence the name discount bond. The yield to maturity. What is yield to maturity? Well, that's the contractual interest rate. That's the interest rate that's agreed upon when the bond is sold. So for a one-period loan, the yield to maturity is the same as the return. Now, if we have more than one period, well, the yield to maturity and the return would not be the same thing. So let P be the price of the loan. The CF is the payout after 1 year, and I is the interest rate. Well, then the price of that loan is equal to the cash flows divided by 1 plus the interest rate. Or 1 plus the interest rate is equal to the cash flows divided by the price. Now, here's what's really interesting. I'm sure you've heard me talk before about like bond prices, interest rates, and how they are inversely related. This is actually how they're inversely related. So if the interest rate goes up because fractions, the price will go down. The price goes up, the interest rate goes down. Prices of bonds and interest rate on bonds are inversely related. Now, the yield to maturity on a discount bond is like the simple loan, but there are different maturities. So for the face value with maturity n periods from now, and a price P, you get P equals F over 1 plus I to the power of n. And we can also express that as 1 plus I equals F over P to the power of 1 over n. Let's do a little example here. Suppose a bond has a face value of $100 and a maturity of 3 years. It pays out coupon payments of $10 in 3 years, in years T plus 1, T plus 2, and T plus 3, with a coupon rate of 10%. The face value is paid off after period T plus 3. And the period T price of the bond is $100. The yield to maturity is the yield under that 100 equals 10 plus 1 plus I plus 10 over 1 plus I squared plus 10 over 1 plus I cubed plus 100 over 1 plus I cubed, which comes out to I, the nominal interest rate, being 0.10. Now, for an n period maturity, you'd have the price being equal to the sum of these cash payments, right, these cash flows, over 1 plus I to the power of j, as j goes from period 1 to infinity, plus at the end, the last period, the face value gets repaid. Now, the coupon rate and the previous examples are the same, but they're not always going to be true. This will be true if the bond sells at par, meaning the price of the bond equals the face value. If the bond sells at a discount to face value, the yield is greater than the coupon rate. And if the bond sells at a premium to face value, the yield is less than the coupon rate. So in general, the coupon rate and the interest rate are not going to be the same thing. Perpetuities, another kind of bond here. Perpetuities are like coupon bonds, but they have no maturity. So the relationship between price, yield, and coupon payments is, well, really nice here. It's I equals C over P. Coupon payments over the price equals the interest rate. So for a coupon bond with a sufficiently long maturity, this is actually a pretty reasonable approximation to the bond's yield to maturity because the present discounted value of the face value after many years is sufficiently close to zero. This is sometimes called the current yield as an approximation to the yield to maturity on a coupon bond. So there's a couple observations I want to go through here. First, the bond price and the yield are negatively related, and this holds for all types of bonds. Bond prices and interest rates will always move in opposite directions. For discount bonds, we don't expect prices to be greater than face value because it would imply a negative yield. You don't really want that. For a coupon bond, when the bond is priced at face value, the yield to maturity equals the coupon rate. And for a coupon bond, when the bond is priced at less than face value, the yield to maturity is greater than the coupon rate, and then vice versa. Now, returns and yields, as I've said, in general, are not the same thing. The rate of return is the cash flow plus the new security price divided by the current price. A good way to think about it is the dividend rate plus capital gain, where the capital gain is the change in the security's price. The return on a coupon bond held from period T to T plus 1 would be R equals C, cash flow, plus the new price minus the old price over the old price. Or we can split it up and have the cash flow over the old price plus the new price minus the old price over the old price, or percent change in the price. So C over P, that's the current yield. And then PT plus 1 minus PT over PT, that's the capital gain. The return is going to differ from the current yield if bond prices unexpectedly fluctuate. Okay, little example time. Say you hold a discount bond with a face value of $1,000, a maturity of 30 years, and a current yield to maturity of, say, $10. The current bond price would then be 1,000 over 1.1 to the power of 30, or $57.31. Now, suppose interest rates stay the same after a year. Then the bond has a price of $63.04 because now it's 1.1 to the power of 29 rather than 1.1 to the power of 30. And since there's no coupon payment, your 1 year holding period return, holding period's the length of time that you choose to hold the security, is really just the capital gain, which is 0.1. Now, in the event that interest rates don't change, the return and the yield to maturity would be the same thing. But suppose interest rates go up to, say, 15% next period, and they're expected to remain there. What happens? Well, the price of the bond in period T plus 1 would be $17.30 or 37 cents. Thus, as the interest rate increases, the bond price itself falls. The return would then be negative 0.69. On a discount bond, an increase in the interest rate exposes you to a capital loss. This is generally true for a coupon bond. While you know the current yield at the time of investment, the capital gain itself is unknown. This is what's known as interest rate risk. The return and the initial yield to maturity are going to be equal if the holding period is the same as the time to maturity, which is 1 period. The capital gain is the face value, which is fixed, minus the initial price. The increase in the interest rate results in returns being less than the initial yield, and then the reverse of that would also hold. And the return is more affected by interest rate changes the longer that change to maturity. So if you hold the bond until maturity, your return's locked at the initial yield to maturity. The concept of return is relevant here because if you don't sell the bond and the concept of return is relevant even if you don't sell the bond and realize that capital lost, because there's still that opportunity cost that you're facing. Now, if the interest rates go up and you hadn't locked yourself into a long maturity bond, then you could have purchased a bond in the future with a higher yield. And longer maturity bonds are thus riskier than short maturity bonds, thus they have a higher interest rate associated with them. Now, if this is all kind of starting to sound a little familiar, think back about a year ago in 2023 when there was all of that issue going on with Silicon Valley Bank. They were essentially exposed to a lot of interest rate risk. And I think we'll be learning about that a little bit later in the semester, time permitting, of course. So if you're like, hey, this sounds kind of familiar, just hold on to that for a couple months. Now, this is going to wrap up this part of the chapter. So we learned about bonds, bond pricing, and yields. Really, the most important takeaway here is that bonds and bond prices are going to be moving in opposite directions. And that implies if the yield of a bond goes down, the price of that bond goes up. And, well, like I said, it has a lot to do with what happened to Silicon Valley Bank in 2023 that triggered a run on a lot of regional banks. Now, in the next lecture, we're going to be learning about the term structure of interest rates, which gives us an idea about the yield curve and the notion that longer-term bonds generally have higher interest rates for various reasons. So thanks for watching, and there will definitely be more to come in the future.